In all of the demos so far, we worked with a number of different types of values: strings, floating points, integers. Let's take a look at the different data types available in Python. These are the built-in data types available by default. You can always create your own data types using classes, but that's far more advanced. We'll come to that when we are ready. We've seen earlier that the type function will give us the data type for a particular value. Type of 23 will tell us that this is of type int, which is a short form for integer. If you pass in a decimal to the type function, the type function will correctly interpret this of type float. This is a short form for floating point numbers. The input argument to a type function can be a variable as well. Here we have the variable named x, which is assigned the value 25, which is an integer. There are a number of details to observe here. Observe that we invoke the print function with 4 arguments. The first is a string data type of, followed by a comma, then x, then is, that is a string in single quotes, and then the type of x. And here is the most interesting bit. We've passed the result of the function type into the print function. So Python will first calculate the result of the type function and pass that result into the print function, and the print function will print out the data type of 25 is int. Now, because x is a variable and not a value, it says class int because int is one of the built-in classes in Python. This additional information, the fact that int is a Python class, is visible to us here because we passed in the result of type to the print function, and the print function displayed this information. All of the other built-in types in Python are also classes. For example, the variable y here is assigned to 8.2, and when you print out the type of y as we do in this print function, you can see that it is of class float. Once again, you don't need to know what exactly classes are. You can just say this is of type float. Now, Python supports not just integers and floating point numeric types, it also supports complex numbers. For example, the variable z here is assigned the value 5j, which indicates that z is a complex number. So if you print out the type of z, you can see that its type is complex. It is of class complex. Python also supports arithmetic operations on complex numbers. You may not use it very often, but you should know that it's possible. 5j multiplied by 5j will give you minus 25 plus 0j. This is a real number, minus 25. If you can't remember complex numbers from your high school math, you can just forget about it. But you should know that working with complex numbers is possible in Python in case you ever have to do so. We worked with Boolean values before. Boolean values can take on 2 forms, true or false. The type of a Boolean value is simply bool. We've also worked with string values before. Here the string commando is assigned to str underscore value, that is the name of the variable, and the type of the variable will be str. This is of class string. Python also gives you the flexibility to specify numbers in the binary, octal, or hexadecimal format. These are different bases for numbers. When you specify numbers in the binary format, you will prefix the binary representation of your number with 0b. Here is the binary number 111. Notice the 0b prefix. This is the number 7, and that is what the print function realizes and prints to screen. Here is a binary number assigned to the value variable 0b101, and 101, as you know, is the number 5, and that's what is printed to screen. If you pass in a binary number to the type function, you'll see that a binary number is nothing but an integer.